Good morning. I'm Ashoka from Cisco, joined by Tim Stevenson and Avinash. Today we are going to talk about telemetry on Nexus platforms. Before we start on the telemetry, I just want to give a quick overview of our SONiC support on Nexus platforms. So we started working on SAI with collaboration with SONiC on our platforms maybe a couple of years back. From last 1 year, we have increased our focus. So we support platforms based on Cisco ASICs and merchant silicon ASICs. So for merchant silicon, we support SONiC on both the platforms, merchant silicon and the Cisco. So on merchant silicon, we provide the platform module, and the SAI and the SDK comes from the chip vendors. We do the integration, and customer, if they want to get SDK directly from the chip vendor, we support that also. For Cisco ASICs, we provide both platform module SDK, which the SDK we use for NXOS, we leverage that SDK here. And on top of that, we add the SAI APIs. So our releases follow the SONiC releases. Once the SONiC releases, within 1 month or couple of months, we release the corresponding release on our platforms. So these are some of the releases we have done in 2018, and currently we are working, or we are about to release the latest one with Warm Boot and VXLAN. So some of the platforms we support are listed here, and it has both merchant silicon platforms and Cisco ASIC platforms. And on the roadmap, we have our 400 gig, which will have Cisco ASIC plus InnoVM. So it's in our roadmap. And these platforms with support breakout, so we have 10 gig, 25 gig, 40 gig, 50 gig, and 100 gig platforms. With that, I'll hand over to.
Okay. Hey, folks. I'm Tim Stevenson. I'm a distinguished DME working on Nexus. Just a couple notes on what we're going to show today. We're going to be showing basically hardware telemetry capability in our homegrown ASIC family known as Cloud Scale Silicon. This is silicon that's developed completely within Cisco, as compared to something like a merchant box based on Barefoot or Broadcom, where we get the ASIC from another vendor and we put our OS on top of it, or SONiC. So this is a family of ASICs. There's a variety of ASICs in this family, and the platform list on the last slide kind of indicated some of them where we've already implemented this. You can see that we use these both to build Tor platforms as well as modular platforms. So the 9300EX, FX, FX2, as well as 9332C and 9364C are all top-of-rack based systems using Cloud Scale Silicon, Cisco's homegrown silicon. And then we also have the 9500EX and FX modular systems, which uses silicon as well. So in terms of network telemetry, obviously there's a whole slew of use cases that are applicable to either hardware or software telemetry or both. We're really focusing on the hardware telemetry capabilities today. So some of these can be addressed using software. We do this in NXOS today. If you have some other OS running on top of it, you would get those software telemetry capabilities via that OS. But in the case of hardware telemetry, you really need to leverage the capabilities of the underlying silicon in order to get things like in-band telemetry, direct export into the forwarding pipeline of telemetry data. And so some of these use cases can really only be addressed using those ASIC capabilities. In terms of Cloud Scale, we have a couple different telemetry features. We lump them into kind of data plane flow analysis based features, and then just ASIC state type features. So the data plane flow stuff would actually capture flow data of the conversations that are happening through the forwarding pipeline inside the ASIC. So this is stuff that typically the control plane would not have knowledge of. We push, an LPM table down, we forward based on the destination IP. You don't know what the conversations happening through the silicon actually are. but with this capability, you can have that. And we also have a flow table event capability that can capture that flow data just on a triggered basis if a packet meets some specific criteria as it's being forwarded. The other bucket is kind of ASIC state data, so it's not specific to the conversations in the silicon. It's more just, can I rapidly collect statistics from the ASIC and stream them out to a collector without any intervention from the CPU or the operating system. And so that's actually the capability that we're going to be demonstrating today using these platforms. So SSX, we call this. This is the hardware feature where at a rapid cadence we can go and read statistic values from the ASIC, package those into an IP UDP packet, insert it at the front of the forwarding pipeline, and forward it toward your collector out of a front panel port. So there's no CPU intervention here. There's no processing in the switch control plane. Everything happens in the silicon, the collection, the encapsulation, and the forwarding decision. Today we're going to demonstrate the capturing of egress queue drops, egress queue peak, and egress queue depth. This is based on capabilities of the SI detail spec. These are things that have been specified already that we can collect, but I should point out that SSX has the capability essentially to capture any counter value, any register value, any table value inside the ASIC, forward it in IP UDP to your collector. So we can, with an expansion of the specification, we can easily capture any data that you want directly out of at the ASIC, and we can do this at sub-second intervals. As I mentioned, it's a direct hardware export, so there's no CPU intervention, and it's supported on the FX2 and the 9330, so that should say 9332C and 9364C cloud scale platforms. With that, I'll hand it over to Avinash.
Hi folks, I'm Avinash. I'm a software engineer in Cisco. So this is just the summary of the demo which we'll be showing today. So we'll be using the SAI detail spec to show the demo. We have the SSX implemented using the SAI detail spec. So we extended the SAI detail spec to support interval-based. Since SSX is interval-based, we report the packets interval-based. And once there is a final spec, telemetry specification finalized, we'll come up with another SSX implementation. So this is going to be the demo topology. So we're going to play a video which has the demo. Should I? Mirror the screen? It's not. What's that? Go to the channel. Settings.
While they are setting up the demo, any questions for the audience?
Are you trying to say something with the elephant in the room?
Yeah, we have some features around elephant flow detection if you want to talk about those while we're waiting. All right, well. That didn't count as the one question, so if there's another question, now that's just black. No, he's just trying to show a video of the same computer.
Should be able to just show the video.
Yeah, the video actually is here, but it's not projecting.
Is it running on your computer?
It's running on the computer, it's just not showing up on that screen. Yeah, it's some mirroring thing or something. Can you drag this over onto that screen?
change the background.
There it is. It's coming. Keep going. Keep going. Yeah, just press play at this point if you can. Or just talk through it. Just talk through it.
Okay.
It's going. Just come down here and talk through it.
Let me just start it from the beginning, I guess. Okay, so essentially, this is the demo topology we'll be using. We have our N9K switch, which is running SONiC, and then we have the collector, which is running UTR, which is running the SSX client to collect the packets and decode the SSX packets. So we are using the SAI detail model, and so essentially this has like 3 parts: the report session, the detail event, and the queue report. So we're using the report session to configure the collector attributes like the destination IP and where the destination port where the client is running. And we use the detail event and queue report to configure the switch. So whatever you see in blue here is an extensions we have added to the SAI detail model to support the interval-based SSX telemetry. So we added a new event type called interval-based, and we provided the support to report the, to specify the report frequency. That is how frequently the packets are exported. Yes. So whatever you see in blue here is the extensions which we have added essentially. The queue report has a bunch of other stuff, and this report frequency just shows that. So this is the demo. So we use the Euclid infrastructure to configure the SSX. So Euclid infrastructure, it provides an abstraction of the SONiC switch and the detail model. And that's our SONiC switch right there. And we also have a collector which decodes the packets, which collects the packets and decodes them. So yeah, I guess this is the simple Euclid script which is doing the configuration. Essentially, it has mainly 3 parts. One is it's configuring the report session, and then we are configuring the detail event, which is interval based. And then we are configuring a queue report by specifying a frequency. So that's a simple script which just configured the switch with those attributes. And on the switch, so I'm doing a save of the configuration of whatever we have configured right now. And this is just viewing all the things which we configured. So that is the detail configuration where the switch is configured in postcard mode. And that's the report session configuration, which is basically the collector attributes. And that is the detail queue report configuration, which specifies the interval frequency. And that is the detail event, which says it's interval based. And it's using the report session 1 attributes to export the packets. So now the switch is configured. So this is on the collector. This is just a TCP dump output of the packets which we are receiving. These are the telemetry packets. And then we run our client script, which actually decodes those packets, and it shows the output. So this is the instantaneous outputs. It's decoding the packets as it comes in. And currently, it's showing the queue occupancy and queue drops. So currently, it's all 0 because there's no data traffic in the switch, but that's the instantaneous output. Now, I'm starting some data traffic on the switch. So here we can see for some of the interfaces, the queue occupancy slightly goes up. So here, the data traffic, the ingress and the egress ports are of pretty much the same bandwidth, so there's no buildup of the queue, and it quickly drains out. So it's slightly marginally higher than 0. But that is the instantaneous output, which SSX is capturing the packets, decoding them, and just dumping it on the screen. Yeah, I guess that's the demo.